All right. Well, good afternoon, everyone. It is my privilege to be able to welcome all of you to session STG303, AWS Storage for Containers and Serverless Applications. My name is Eric Heinrichs. I am a storage specialist solutions architect here at Amazon. And today you're going to be hearing from myself as well as from a couple of my colleagues, Jeremiah and Higgy, who are going to be talking a little bit more in depth about container services and serverless. So you'll be hearing from them in just a bit. To start off, though, I'm just going to review the agenda and the overview of what we're going to cover today. So first and foremost, we're going to talk a little bit about what makes an application a modern application. And then we're going to get a little bit more specific and talk in depth about a couple of our key storage services to support serverless and modern applications today, namely Amazon EFS and S3. And then at the end, we're going to try to kind of wrap it all together and give you a couple of customer examples and use cases that hopefully are relevant to each of you in your own businesses in supporting your own environments. So with that, we're going to kick it off here. So when we talk about serverless and when we talk about modernizing applications, what do we mean by that? Well, for many of us, myself included, we came from a world that was really rooted in the data center. And typically, when we designed applications, when we deploy applications, it sat on top of an infrastructure stack that typically was comprised of compute, storage, and network resources, all kind of tightly coupled together in a monolithic type of an application stack. And as time has kind of progressed, many customers have shifted from that monolithic approach to a more distributed architecture, where now microservices are becoming the norm. And we start to see smaller units of compute and network and storage all interwoven together and loosely coupled with different services that allow them to communicate and offer greater flexibility and scale. Now, when we talk about what is modern, by definition, what's modern today is not necessarily going to be what's modern in the future. In fact, what's modern today may be antiquated and even irrelevant in the not so distant future. So we have this process of continuous innovation and continuous deployment, continuous modernization, where things become more efficient, more scalable, more performant over time. And that's really one of the key hallmarks of what we talk about when we talk about application and infrastructure modernization. So here at AWS, we have the benefit of a rich heritage of Amazon.com. And many of the services that our customers take advantage of today really come from this heritage of running one of the largest e-commerce platforms on the planet, and all of the capabilities that have gone into that over time. And they're now available to you and to our customers in terms of our services. So things like fine-grained access, event-driven programming models, and programmatic governance to be able to secure applications and make sure that they are compliant and meet all of the needs of enterprises today. So why modernize? Well, is it just because it's cool? Is it just because everyone's doing it? Well, no, there's some other benefits that customers can take advantage of. Notably, there are some economic values to doing this, right? So we can save cost by reducing the operational overhead and burden of our applications. And again, many of us who came from the data center world struggled with, how do we really plan for the future when designing infrastructure? There's always that constant challenge of over-provisioning versus under-provisioning. And if I over-provision, there's a lot of inherent waste with that. But if I under-provision, then I might not be serving the needs of my customers, right? And that leads us into this idea of agility. So again, Amazon.com as a great example of this. We just had Black Friday and Cyber Monday, and what would happen if Amazon.com were to pre-provision all the resources that it needed to be able to sustain these large events where customers are hitting the website, and to keep all those resources deployed year-round. Well, there'd be a lot of waste in that, right? So the ability to expand and contract and offer on-demand services that grow in strength depending on the needs of the environment become really crucial in a modern application infrastructure. And then being able to shift from this idea of focusing on infrastructure to really focusing on the applications themselves and being able to deploy code in such a way that you can spend your time developing your product and not the infrastructure that it sits on. So we said this was a storage session, so let's talk a little bit about storage now. When modernizing your infrastructure, there are some really key components as it relates to storage. So number one, storage needs to be available and it needs to be highly durable, right? Not every compute resource needs to have stateful applications today. There are a lot of stateless apps where data might be transient, it might be short-lived. But for those long-running applications, we need to provide a durable storage infrastructure component so that those compute instances are able to leverage that asset. And with that, many of these applications take advantage of high degrees of scale when it comes to the compute. So you may have tens or hundreds or even thousands of compute nodes that are taking advantage of a single storage resource, and that resource needs to be shared across all of those components. And then lastly, scalability is really important when designing modern applications, not only to be able to support big data workloads for things like Hadoop and EMR and AI/ML workloads, but also distributed systems, so things that run in containers on Kubernetes or on our ECS platform. All right, so I want to talk a little bit more specifically about one of our key storage services. So by show of hands, who in the room is familiar with Amazon EFS? Okay, great. So EFS has been around for a number of years now. When our developers set out to create a truly native cloud file system solution, they really had one key goal in mind, and that would be that in the cloud era, there would be a storage solution that would just work, okay? Instead of having to, again, have that trade-off of over-provisioning or under-provisioning. What if the storage itself could respond to the needs of the application and to the end users, and that you would only have to pay for what you're using? So with an EFS file system, you put the data in, the file system grows as you add more data. As you take data out, the file system contracts, and you're only charged for what you're storing in that file system. The other component that was really important was durability and availability of the data. So our customers have come to rely on that 11 nines of durability that they're used to with S3. And from an availability perspective, having the ability to store data across multiple availability zones within a region is really important. So EFS offers both of those capabilities as well. So when you write data to EFS, you know that the data that you request is the same data that you put in, and it's going to be available when you need it. And as we talk about modernization, EFS can become a great cornerstone of modernizing compute resources as customers shift from that monolithic architecture into microservices and start to take advantage of container services as well as serverless capabilities like Amazon Fargate and Lambda. And of course, performance becomes really important when you're talking about these modern applications. So the developers on the EFS team have always been hard at work at continually optimizing, reducing latency while increasing throughput and IOPS on the platform. And some of you may have caught the announcement a couple of days ago that once again, we've been able to reduce that latency, particularly for read requests on EFS. And then lastly, from a cost perspective, I mentioned you only pay for what you use in EFS. And about a year ago, we also made the story even better by introducing intelligent tiering into EFS. So much like S3, you can now store data efficiently in EFS, and the data will automatically tier down to lower cost storage without you as an end user having to configure anything. And then if that data is accessed again, it will automatically promote that back up into the standard tier. So we're constantly optimizing that trade-off between performance and cost on your behalf. All right, so how do we get from point A to point B? Well, for many of our customers, they start out in the data center and they want to modernize, they want to move to the cloud. And step one is just getting the data to the cloud, right? So these monolithic applications will move from an on-premises deployment into the cloud. And oftentimes, the compute resources that they leverage are going to be individual EC2 instances, right? So they still have kind of that monolithic profile to them. Well, it turns out if you use EFS as that persistent storage layer, it makes it very easy to begin to modernize and transition into serverless technologies and container-based strategies using ECS or EKS and Fargate and Lambda. And even dedicated, purpose-built services like Amazon SageMaker for AI ML workloads and those sorts of applications. And the story just keeps getting better and better over time. As we continue to modernize, as we continue to innovate and add new features and functionality to these services, the story gets better from a performance perspective, from a cost optimization perspective, and customers are able to take advantage of the newest iterations of our technology. And with that, I'd like to bring up Jeremiah, who's going to talk a little bit about container services.
Hello, everybody. My name is Jeremiah Dooley, and I run the advocacy team that covers Amazon ECS, App Runner, Elastic Beanstalk, App Mesh, and the newly released Service Connect. Eric teased this up really well for me. What we know from his introduction is that EFS is a great solution in general, but specifically, it works really well with that concept of continuous innovation that he talked about, continuous modernization. What we see is customers who are bringing applications in that are currently running on EC2 instances or on-premises servers, and they're containerizing those applications. They're containerizing it to reduce the amount of operational overhead. They're containerizing it to simplify the deployment. They're also using this process to right-size on the compute, because as we containerize things, we can be more efficient about the instance sizes that we're using. And we're building something that has inherent scalability native to it. We can be much more elastically flexible in how we build these up. Using EFS, we can persist storage across containers so that even workloads that need to have shared or persistent storage can be migrated. We pay for what we use. We let Amazon handle the undifferentiated heavy lifting of the infrastructure side of it. And we give customers the ability to create and manage multi-tenant environments natively through the tools that they have, through the IAM parameters that they have, through the access points that the different pieces of technology offer. EFS is designed to serve the vast majority of the file-based workloads that you're going to bring to us every day. In particular, though, there are 3 use cases that we see that line up really, really well for the strengths that EFS brings to the table: scalable digital experiences, machine learning inference, and media processing. We're going to look at an example of all 3 of these as we go through here, and I'm hoping that you can see where the 2 of them together, the container technologies, the serverless technologies, and EFS really shine. First and probably most common of all of these use cases are the scalable digital experiences. Think of all of the apps that are out there whose only job is to create, modify, and serve digital content out to end users. This can be something multi-tiered. Think of something with a database in the back end like a WordPress instance or a Drupal instance. This could be a static website, something created with Ghost or Hugo, or this could be something that's never been seen before that you've developed in-house and that is unique to your company or to your business. The challenge is always the same, right? How do we get the content to the users? The special part of it is we don't really ever know how many users are going to come get that content and how often they're going to do it. Building an app for 10 users is way different than building an app for 10 million users. And what we want to give you is the infrastructure to be able to move from one to the other of those as seamlessly and painlessly as possible. Take any content management system, and the goal is to take as many users as you have and get it to your content by spreading the load of those users across as many instances as you can manage. Instances that are highly resilient, that are deployed into different AZs, that offer scalability, that offer flexibility. Because EFS standard is regional, all of those container instances can easily mount the same file system and then access that file system as updates are made. So I can make an update in one region, and all of the rest of the containers that are accessing that same file system are going to be able to see those changes that are made. You can see here that we've chosen Aurora Serverless as the database to support this workload. And what that gives us is an entire platform where I don't have to care about the infrastructure. Amazon is managing the container orchestration through ECS or EKS. Amazon is managing the compute through Fargate. EFS is handling all of the storage infrastructure, and Aurora is handling the database. Developer teams can focus on how do I build the best application to solve that challenge of getting content from the system to the users. We mentioned ECS and EKS, and I want to take a minute and walk through each of those platforms and show you how we would take an application that is inherently scalable, that you don't know how many containers at any point in time are going to be running, and still be able to support it with consistent, persistent storage on the back end. For EKS, we've integrated EFS directly into the container storage interface driver. The interface driver ends up making something that can be pretty complex in vanilla Kubernetes a lot simpler. The first thing that we need to do on the EKS side is we have to create a persistent volume claim. The CSI driver then takes that and creates an access point into the file system on EFS, and then maps that to a persistent volume, which it gives back to the customer, who can then use that persistent volume inside their application definition. Each access point created by the CSI driver enforces a unique identity and root directory to ensure that the application data is private to a persistent volume, and that's it. We now have the ability to scale our Kubernetes-driven application up or down as much as we need to across as many AZs as we want to, and we're always going to have access to that shared storage on the backside. A good example of a customer using this exact setup would be Acquia, who modernized a web hosting platform where their two challenges were scaling the compute and the storage. By using EKS for the compute and using EFS for the persistent storage, they were really starting to drive down internal costs, both the infrastructure overhead and the management overhead, but that directly translated into the customers having a better experience because provisioning was faster, there were less things that needed to be done manually in the process. So again, EKS being the orchestrator, running all of the containerized applications, using the CSI driver to connect to a file system presented by EFS across the entire footprint of the application. On ECS, the process is a little bit different because we don't need a CSI driver. We're already inside the Amazon API. EFS and ECS are both Amazon products. We don't need to create an external mechanism to be able to integrate the two of them. We can do that directly. On the ECS side, the first thing we're going to do is we're going to set up our cluster. And it doesn't matter what kind of cluster we set up. We can have this be backed by EC2 instances that we manage directly. We can have this be backed by Fargate instances that AWS is managing. They can be Linux, they can be Windows, doesn't matter. We stand up the cluster, and the next thing that we're going to do is we're going to create a security group. And the security group allows the inbound NFS connections, in this case it's port 2049. We can also isolate this to a specific subnet. So if we had far more complex environments than we do for the quick demo that we're showing here, we would have the ability to take that traffic and pin it to a specific subnet to make sure that everything is where we need it to be. Once we have the security group set up, then we go to EFS console and we create the actual file system. And we're just creating a regular, your straightforward ECS standard, regional service, stand up the file system, name it whatever we want to. We have our two pieces. We have the security group, we have EFS, now we need to tie them together. The construct that we use to tie these together in ECS is the task definition. So think of the task definition as the way that we describe all of the containers that are going to work together. They're going to be deployed together, that are going to scale together in order to support an application function. Once we create this task definition, then we tie the two pieces that we have together. We take the file system ID from the volume, and we take the mount point from EFS. We put them together. We could do this through the UI. We could do this straight through the YAML output of the task definition. But now we've created a secure way to directly attach one task definition, one discrete set of containers to elastic, scalable storage on the back end, regardless of how much we scale it up or how much we scale it back in. A good example of this is AstraZeneca and NVIDIA. And this is one of my favorite case studies that we've done. And if this looks interesting to you, if you search for AstraZeneca and ECS on the AWS website, there are architectural details, lots of overviews to be able to dig into. The idea was what they wanted to power was a computational drug discovery process that they could do in real time. So they weren't collecting data and then batching data. They wanted to be able to run everything through together. They needed elasticity on both the container level, the individual task level, because not all of the task definitions were going to scale at the same time, depending on what type of functions they were running. And then they wanted to bring all of that back through a UI that the actual chemists themselves could work through. So driving that idea to lower the barrier to entry for the development efforts of the actual drug discovery process was the end result. ECS scaling at the compute layer for the containers being used, and EFS scaling and supporting all of the storage underneath it were the two things that they put together to make that happen. Remember our three perfect EFS use cases? I want to take a look at the other two, machine learning inference and media processing. Instead of containers, though, since we've talked about ECS, we've talked about EKS, let's talk a little bit about Lambda, and let's show you how customers can choose Lambda and still take advantage of the capabilities of EFS. Customers are building serverless apps by using EFS as shared storage behind them. And you may ask yourself, why are they doing that? Lambda functions, you invoke it, it runs, it stops running. Why would I want to have persistent storage behind there? So there's a couple good reasons. The first one is that EFS provides petabyte scale storage that we can attach directly to Lambda functions. This is important because a Lambda function, as it comes, gets provisioned an amount of space in its temp directory, and that's all you can get. So if you have a data set that's larger than that you need to work on, you can't natively inside a Lambda function. EFS removes that limitation and gives you as much storage as you could possibly want to be able to bring data into the function in order to be able to run a process. By saving the state of the function at the end of the processing and then loading that state at the beginning of the next processing, we can also allow customers to bring state, to build stateful applications on top of an event-driven infrastructure. Just like everywhere else, EFS provides the low latency. It lets you pay for only what you're using. It lets Amazon handle the infrastructure costs. And at the end, what we get are customers who can build scalable applications, sharing data across tens of thousands of function invocations. What does this look like? What is a real-world example of this? So here's an example application where a customer is sending the image of a signpost in Chinese to an application where they want to extract the text. They can extract the text from the image, and they want to generate the predicted label and then return that back to the customer. So it looks pretty straightforward, not a whole lot of moving parts, until we go under the hood, and there's a few more pieces that I want to talk through. Machine learning inference is one of the most common applications that our customers are modernizing with Lambda. And the inference part, I'm sure everybody's heard of machine learning, the inference part is the real-time part of machine learning. So after you've used historical data to build a model, you then want to use that model to predict or classify new users, new events, anything that's coming in. So that's the inference part of this. The first thing we're going to do is we're going to take that model that was built, we're going to load it into EFS. This is the EFS that we have presented to the function. The function shows up because a client issues a user request by uploading a photo. That upload triggers the Lambda function, which then loads the model from EFS, runs the prediction, extracts the text, predicts the label, and then gives that back to the customer. EFS and Lambda are obviously pretty attractive for these inference use cases because they're completely elastic. Not only can I use models as big as I want to, but unless I'm running a prediction, unless I'm running the model against a user input, I'm not paying for it. The only time I'm going to be paying for it is when I'm actually using it. So how do we get those models visible? We have them in EFS. We know how to load things into EFS. How do I get that visible to a Lambda function? Unlike with EFS, or unlike with ECS, where we used the security group, the process is going to feel the same, but is going to be done in a little bit different way with Lambda. So we go into EFS and we create our file system the same way we always do. In Lambda, in the console, what we're going to create is an access point. Right? The access points provide application-specific entry points into the file system data. With access points, you can synchronize permissions and prevent privilege escalation by enforcing the identity of all inbound connections that are using that access point. This is particularly useful with serverless functions where there's no first-class notion of POSIX identity. This is the place where we can really start to build walls to maintain separation between the things that need to be separated. We then use the Lambda console to create the function, and now we're at the same place we were with ECS. We have a file system, we have a security mechanism, we have the thing we want to attach it to, and straight through the console, we're going to take the two of them and we're going to put them together. We're going to take the EFS file system that we created, the access point that we created, we're going to attach them together to the function, and now every time that function runs, it's going to have that capability, it's going to have that attachment to the storage that's on the back end. So just like that, by provisioning a file system, creating an access point, and attaching it to a function, we've unlocked an entirely different set of capabilities for Lambda, simply because we have low latency, scalable, high-performance storage on the backside. A customer who's using this today would be Asurion. Asurion creates and services service contracts for consumer electronics. And customer service is a big part of their job. And so they wanted to model against call recordings to make sure that their staff were friendly, make sure they were engaged, make sure that that customer service was as good as it could be. Their challenges were the call recordings were way too big to fit inside the standard temp directory that was provisioned with the Lambda side of things, and their call volume varied throughout the day, so they didn't know how many of these they were going to need to run. They really wanted to use Lambda so they could do this as a pay-as-you-go type environment. By using EFS on the back end, we fixed both those problems. We gave them the high-performance storage. We also overcame the inherent limitation of the storage on the Lambda side of things, and we built them the pay-as-you-go model that they were looking for. That ML infrastructure, the ML inference infrastructure, is really easily extended into image processing as well. For SkyWatch, processing satellite images was challenging because, again, the satellite images were large and didn't always fit inside the Lambda temp space, and their processing time was really slow, even when they were able to make it work. By introducing EFS to store the satellite images, it enabled them not only to do concurrent processing pipelines, so they could process multiple images at a time, it also allowed for much lower latencies on the processing path as it was. So again, these two basic challenges that we see with large images and functions, EFS solves for us pretty well. So to wrap up the EFS part of the session, we covered 3 categories of use cases for developing containerized and serverless applications. We talked about scalable digital experiences, we talked about machine learning inference, and we talked about media processing. What we're going to do next is, instead of EFS, we're going to talk about how we can use S3 and really lean into the event-driven side of the serverless architectures. And for that, I'm going to turn it over to somebody who probably knows Lambda as well as anybody in the world, Higgy Park.
Cool, thank you, Jeremiah. So my name is Higgy Park. I'm a specialist solutions architect at AWS. I've been here about six plus years, and for the last 2.5 years, I've been really focused on helping customers build serverless architectures. How do we think about event-driven applications? How do we think about all the governance, the guardrails, the security models, the developer tool chains? What does the developer experience look like when we want to build these type of applications? So we're gonna look a little bit at what that looks like with S3 and what we mean by event-driven architectures. So one thing that a lot of customers think about is when you're building kind of large-scale applications, the traditional model has been, I have a certain amount of data. I have data in a relational database. Maybe I have some data sitting in some type of data warehouse. And oftentimes, you're going to bring that compute layer to the data. So you're going to have an application. Maybe if it's a Java-based application, you have an ODBC or JDBC connection. You go and query that relational database. You're going to go and extract the data out of that database. You then go and retrieve and process that data. And that's traditionally been the computing model that we've often seen. What we want to think about is we want to kind of invert that model, where you have S3, and you may have data residing within that S3 environment, and maybe that can trigger what we call an event, some type of notification that something has happened in that S3 bucket. So an example could be something like, I have an image processing application. I've just put a new image into that bucket, and now I want to immediately take action. Traditionally, you might have done things like, we're going to put it in a large, some type of large storage system, and then you're going to run a batch job overnight. So maybe you're using AutoSys or Control-M, and then you're going to run that job at 8 p.m. or 10 p.m. at night, and then it'll chunk through all of that image processing overnight. But what if instead of waiting for that batch process, you can say, I've retrieved an event or a notification that something has just happened, and I want to take immediate action against that. So this is an example where you can have an image put into an S3 bucket. It triggers an event notification that says, an object was just put into this bucket. Is there anything that you want to do with that? And with that, we can do things like trigger a Lambda function to then go and immediately do some computation against that image. So just thinking about those event notifications, we have on the order of 131 billion events coming out of S3 on a daily basis. So these are events that customers are now acting upon in kind of near real-time fashion to be able to do, again, a number of different activities. And we're going to walk through some of those use cases. So you might be asking, like, all right, this S3 event notification, that sounds great. What do I actually do with that event notification? So a couple things to think about is, with this event notification, it is an at least once delivery of that event. So the idea here is, when you're developing your applications, if you're a developer, you need the ability to handle multiple duplicate events. So for example, there's a put object event. Maybe there was some network transit problems, or some blip may have happened. And we may actually send that event notification to you twice. So you, as a developer, you want to make sure that if there's some downstream effect, there's kind of this idea of idempotency when you're developing your application, so that if I'm going to increment or change the value of some data in a database, we want to make sure that if I actually run that twice against the same event, that there's no downstream residual impact. So we do have a number of different delivery destinations here. There's 3 that we've listed up here. One is SQS, our simple queue service. So oftentimes, we use things like queues as decoupling mechanisms between our applications. So an idea here would be, you could potentially have, let's say, thousands or maybe millions of event notifications happening. And maybe you're going to invoke a Lambda function on the back end of that queue. But maybe that Lambda function, maybe it's going to spin up to thousands of concurrent invokes. But maybe it's actually hitting a relational database on-prem. And maybe that relational database on-prem is not in a place where you want to receive that many concurrent new connection requests in that short a period of time. Right? So sometimes we'll use queues as a decoupling mechanism to make sure that we don't create thundering herd problems, and then we don't create downstream kind of back pressure issues. SNS, our simple notification service, is a mechanism for doing downstream notifications and fan out. So there's 2 different ways that we can work with it. One is kind of a application to person type notification. So you can imagine with SNS, you can create a topic. You can then subscribe your mobile phone to it. So you can get SMS notifications. The other mechanism is what we call application to application. And that's probably more relevant in this particular scenario. And this is where you can subscribe another queue if you wanted to. You could actually subscribe a Lambda function so that on a message coming into that topic, it will actually invoke a Lambda function. The idea here is that you want to actually have a fan-out mechanism. So you can actually subscribe multiple Lambda functions to this topic, and each of them may do actually different functions against that event notification. And then, of course, we have Lambda, which will be your function as a service. You can write code that will do whatever processing that you want to do against it. So we'll talk through some use cases in a little bit. But you may be asking, OK, how do I configure this, similar to what Jeremiah just walked through? If I want to configure an S3 event notification, here you'll see on the bottom, there's this event notification section here. You can go ahead and create the event notification. And then we're going to go ahead and configure a number of different parameters. And of course, some things that you may want to be thinking about is there a particular prefix within my S3 bucket that I actually particularly care about? So maybe, again, we're talking about images. So maybe there's a /images prefix. And I want to invoke my Lambda function if and only if there are new images that are within that particular prefix. You can also configure event notifications on particular events. So if you were doing something like a put event or a put object, and you only care about when new objects are being created within that bucket, then, and if and only then, would I want to actually invoke this Lambda function. You could do likewise if you were doing a copy, maybe you're doing a delete. So again, these could be different auditing functions against your S3 bucket. And again, you'll see on the right side, we talked about the 3 different event targets. And in this case, we're choosing a Lambda function. And you can then go ahead and select a pre-existing Lambda function, ARN, or Amazon Resource Name. So let's go into some examples. So perhaps you have an application, or maybe you have a document repository. In that document repository, you have a number of different documents. And again, I'm an English language speaker, and maybe all of my documents today are all in English. So maybe I have thousands and thousands of PDF documents written in English. But now I'm taking my business, and I want to be more globally aware. So I have customers perhaps in China, perhaps in EMEA with other languages, Spanish, French, et cetera. One way to potentially go about thinking about this is as new documents are ingested. Again, we talked before about maybe there's a batch processing mode. Every night, we're going to go in, scan for new PDF documents, and then I can go ahead and run a translation service against all of those every night. And then the next day, you'll have the document in whatever languages that you may want. But as we were talking about, maybe we could do something with this event notification that we got out of our S3 bucket. So maybe we could do something like here. So I drop a new PDF document, and then maybe I trigger that Lambda function. And with that Lambda function, I'm going to make a call to our Amazon Translate service. So the Translate service then supports translation between a number of different languages. The Translate service will then return back to me the text document in whatever the requested language may have been. And then maybe within my code, I can use a library to then package up that text document in that new language and write it as a PDF document back into the S3 bucket. Now what we've done is we could actually trigger multiple of these functions. And so again, if there are 4, 5, 6, 7 different languages that I want to support for my customer base, I now have the ability to just put in one English PDF document. And now using these event notifications, I've now produced 7, 8, 10 different language documents in near real time. Now, as you continue to scale this, maybe you're thinking as an organization, that's great as I do it on a one-by-one basis, but maybe I'm going to be processing thousands of these. Maybe these are invoices. Maybe these are notices to your customers, and I'm going to actually need to generate thousands of these. And I want to make sure that I have a resilient architecture that handles maybe API limits or maybe failure scenarios that may have happened in your environment. So we may want to start scaling the system. So this is where we start to see some of what we call event-driven architecture. So we're going to use queues. We're going to use Lambda in a number of different ways. So if we walk from left to right here, we're going to have what we call an Amazon S3 a batching bucket. So what we may want to think about is we're going to take large numbers of documents, and maybe we're going to put them into small batches. So maybe we could do things like we're going to take 10 of these PDF documents, and we'll zip them up as a singular artifact using that batching function, and we'll put that into this translation S3 bucket. So it's kind of like our interim S3 bucket. Then what we'll do is, again, as you remember, we have 3 different destinations for that event trigger. One was the Lambda function, which is what we did in the first case. But now what we want to do is we're going to use that SQS queue, again, as that decoupling mechanism. right? And the idea here is we're going to think of that queue as a work queue. We're going to actually start putting in large numbers of requests for these translations. The reason for that is with Amazon Translate, it does have certain API limits that we want to abide by. So we've put that work into this queue. We then have this translation function that's going to then go, and perhaps we're going to make 5 requests per second as an example. We'll go get the translated payload as we got before. And now here we're going to do actually 2 different things. One is we'll certainly store the output of the batch, I guess the PDF translations, into this resultant bucket, but we'll also write some of the metadata into a Dynamo table. And now you can imagine maybe as an operator or maybe as some type of business analyst, you may want a dashboard. You want a dashboard to understand, hey, I just put in 10,000 document translation requests. What's my status? So you can actually use the translation function to be putting metadata into the DynamoDB table. And now this dashboard is getting real-time updates from this DynamoDB table that's saying, you know what, you've submitted 1,000 job requests. We're currently at 5,000. And hey, by the way, there were 5 of them that have failed and maybe are sitting in some dead letter queue for me to go and do some subsequent processing. Or maybe we need to do some additional analysis to understand why did that particular document fail. Maybe there were characters or maybe there was stuff that we just didn't understand in that document. Another thing that you maybe want to do as an organization, and you're probably familiar with this, is you have some type of business workflow. You know, if this happens, then we're going to do that type of business workflow. Alternatively, if this doesn't happen, maybe there's another workflow that we may want to take. And the idea here is you can model your business workflows essentially as a state machine. And one thing that we can potentially do here is use something called AWS step functions. So step functions is what we use for doing business type orchestration. So here's an example where we're going to be, again, maybe we put a document or we put some type of artifact into our S3 bucket. We'll then use a Lambda function to trigger a step function execution workflow. Now, in this example, let's suppose it's an image or some type of, again, some type of image that you've put into the S3 bucket. And in this decider function, you go and retrieve that image, and maybe you're going to then make a call to our Amazon recognition service. Our recognition service can do some machine learning modeling and actually extract metadata about that image. So for example, maybe you're going to say, does this image contain an image of a cat, a dog, or maybe any type of animal? And so if, for example, I have this, in this use case, I just want to know, does this picture have a picture of a cat inside of this image at any point? And so this decider function will simply respond yes or no. And so based on that business logic, you can say, if it did contain an image of a cat, maybe we'll go to our match function and then do whatever appropriate business logic if it had a cat. And then again, if not, maybe there's some other business logic. Maybe you respond back to your end user and say, hey, you didn't give me a picture with a cat in it. So again, this allows you to be able to do things like choice logic. So if this, then that. There's actually more capability within step functions where you could do things like parallel logic, where you can actually say, I'm going to determine does it have a cat or not. Maybe I'll put some metadata in a DynamoDB database. Maybe I'll store this in a smaller thumbnail image for smaller processing. And you could do all 3 of those things in parallel so that all of these workflows are happening and it happens much quicker rather than doing it in a serial fashion. Another example that we've had with some of our customers is with call centers. So I'm sure if I were to do a poll in this audience, how many of you have ever made a call to support calls? And then on the support call, typically you hear something like, please stand by. Please be aware that this call will be recorded for training and testing purposes. Again, so you could imagine that when you're doing that support call, they're going to record that call. Maybe they'll store that recording in S3. And maybe as a business now, with that call recording, there's some analytics you may want to do with that. So here's an example of what you could potentially do using Lambda and some of these other services. So again, you'll have your S3 bucket. Maybe that call recording is stored as an MP3 file and gets stored into this audio S3 bucket. Now again, we're going to trigger a Lambda function. And maybe what we want to do in this case is it's an audio file. I want to convert that into a text file so that I could do some additional analysis here. So we can call our AWS transcribe service, which will convert audio files into text documents. Then what we can do is take the output of that transcription, put into this transcription bucket, and then we're going to continue and do one more thing with that. So we'll store that data in a transcription bucket. And now what we may want to do is as a business or an organization, you've attached metadata to that transcription. So maybe you're a retail organization. I have metadata about the product that this support call is about. Maybe I have metadata about the demographics of my users. And now I'm going to make a call to comprehend and get, was this customer happy or was this customer upset? And maybe what you can do is you can store that data into a DynamoDB table. And now as business analysts, you can go and say, is there a correlation between product IDs and negative sentiment? Maybe over a short period of time, you may find that within the last 30 days for product X, we've had 500 negative sentiment calls for this particular product, whereas before this, for the preceding 6 months, there were lots of maybe not so negative calls about this particular product. And so this allows you to create some different workflows where it was just a support audio call, but now you can start to extract some value out of those audio recordings. So as we continue to think about serverless architectures, again, we talked about SNS. And again, as I had mentioned before, in this application-to-application scenario, you can fan out and do many different things. So here you'll see examples of 3 different Lambda functions, and each of them perhaps doing different compute. And then again, an SQS queue, which you can subscribe from a topic. But another kind of architectural paradigm that we can have with serverless architectures is, how do we maybe simplify this? Because one thing that's challenging here is that every time I want to add a new target or a new compute option, that has to be a new subscription into that topic. So one way to actually make this pretty simple from an extensibility standpoint is we have this other service called Amazon EventBridge. And what EventBridge does is, we'll go to the next slide, is it does a number of different things. So one is, you can think of EventBridge really as an event router, right? So with that S3 event notification, it has essentially a JSON object and a JSON schema. And there are different key value pairs in there. Now, what you may want to do is, you may want to say, I want to look at the event prefixes for the objects that are generated in there. And based on those prefixes, maybe I'm going to have different routing logic or different business logic. So you could actually filter based on values within the event payload to then hit different targets. This allows you to do this in an extensible way. It also allows you to create multiple rules for the same event. So one nice thing that you have here is, for a single put object event, if we were attaching a Lambda function directly from it, it would be a single Lambda invoke against that one event notification. If instead we redirect that to EventBridge, what we can now do is create multiple event rules and hit many, many different targets, somewhat akin to what we saw before with the SNS topics. So you may ask, how do we actually go ahead and create that? Actually, right below the event notifications where we configured the target destinations before, there is an EventBridge section there. We can go ahead and configure, as I was mentioning, there's these different parameters. So you can configure different JSON schema that essentially that you want to match on this particular event. So you can specify these prefixes for these events. And then again, you would specify, in this case, a Lambda function that you want to target for an invoke. So one thing that you could do, here's a use case where we start to tie in some of these things that we had just talked about together. So maybe we want to look at the suffix of that event payload. If it's an MP3 file, maybe this is an audio recording that was just put into my S3 bucket, and I want to do a transcribe action against it. Now we got the result of that as a JSON object, and maybe that same kind of application is just going to send another event through EventBridge. And now that we see a JSON object, we say, OK, now we want to do a translation. Maybe we're going to translate this into a different language, or maybe we're going to make a call to comprehend for that sentiment analysis. So this allows you to do rule-based filtering on the events that are coming in and perform different activities. So one other thing that I want to talk about, so it's kind of transitioning a little bit with S3, is this is S3 Object Lambda, which we had announced last year. And one thing that you could potentially do is, if we go back to that example before, I have PDF documents. We could certainly do a scenario where I'm going to put an English PDF document in my S3 bucket. I'll trigger a Lambda function, and then I'll maybe translate that into 5 different languages. In that scenario, we've done that in near real time, so we don't have to worry about large-scale batch processing at night. But one thing that you do have to think about is the additional storage cost. So in this scenario, you're actually storing many derivative copies of that same document. It just happens to be in different languages because you wanted to do that as a pre-process. What S3 Object Lambda does, it then allows you to do this inline. And we'll talk a little bit of what that looks like. So with S3 Object Lambda, you can actually invoke a Lambda function inline for, let's say, that GET request. It also includes head and list, which we just released last month. But the idea here is you can write code or business logic within your Lambda function. And when you essentially do that, the S3 GET for that particular PDF document, instead of having multiple copies, so maybe there's a document.english, document.french, document.spanish, et cetera. Now we just say, just give me the document, and maybe as part of the request, there's a header or some type of information you're passing in there that indicates, I want this actually in Spanish. And now your Lambda function can look at that event payload and say, the end user has requested this PDF document, which currently is in English. They've requested it in Spanish. I'm going to make that transcribe call inline, get the translation, convert it to PDF, and then send that out. And now we don't actually have multiple derivative copies. Other examples or use cases is you may actually want to filter rows. So let's suppose you have a CSV file. And maybe in that CSV file, there's some type of column that indicates identity or maybe group. Maybe there's the finance group, the HR group, and maybe you want to return only a portion of that document. What you could do is you could actually have an Object Lambda function that's checking for maybe authorization of data rows within your data object. And you could then filter out and say, you know what, I'm going to remove rows within this CSV file that this particular end user is not allowed to see, or maybe, again, say that this end user is only allowed to see. Likewise, we had talked about image resizing. You could do things like thumbnail generation inline. So again, before I used to talk about, you upload a picture into an S3 bucket. You run a Lambda function that has the ability to generate thumbnail images and do that based on that trigger. But now you could do that with the Object Lambda inline. Likewise, to redact data. So again, maybe that CSV file has PII data in there. Maybe it has PCI data in there. So social security numbers, credit card numbers, phone numbers, email addresses, things that you wouldn't want to expose. So you could, again, think about maybe I'm a security, compliance, governance person, and I actually need access to see that data to see if there are violations. But maybe there's just an operator, and they're just checking to see if everything is well with the data. But that operator really doesn't need to see that PII or PCI data. And in this case, you would want to redact the data. So you can maybe replace any sensitive information with maybe a bunch of pound symbols. So here's a little bit of an architecture of essentially what happens. Really, the basic of it is that your application, instead of directly hitting the S3 endpoint, you're going to now hit a Object Lambda access point. Similar to when Jeremiah was talking about access points with EFS, this just becomes a different access point because this access point now is used to then invoke the Lambda function that's going to be that Object Lambda function. So here's just the stepwise process. I know that we're running a little bit short on time. This is the stepwise process for doing so. You would create the S3 access point. You then author your Lambda function. Again, you could maybe do it through the console, or maybe you as a developer will write that on your developer laptop and use different developer tools to get that deployed into your environment. And then you would then connect that with the S3 object access point, and then you would want to update your application to redirect and point to that access point. So again, we talked about a couple of different things. So these are other use cases where we've seen some of our customers with S3 Object Lambda doing things like compression, decompression. So you can imagine, for example, you have images or documents, maybe that's a mobile device, and you have customers that are maybe in areas where you don't necessarily have 4G connectivity, and you would want to reduce the amount of data that's being transmitted via a wireless connection. So you can maybe compress the data on a GET to make sure that you minimize the amount of data that's transmitted over that network. Things like audio-video transcoding. So again, we would want to think about, is it necessarily, because sometimes you have large files, which maybe you don't want to necessarily do that inline. But if you're transmitting small audio files, and maybe you want to convert from one encoding to another, or maybe you have HLS video files, and maybe you want to down-rev the resolution and do that inline based on small image segments. You could do things like custom authorization, again, like we were talking about with redaction. And then we also talked about image resizing and watermarking. Here's a cool example of one customer that actually went and used this. So again, I'm sure many of us are happy that we're farther along in the pandemic than when we were in 2022, and there's a little bit more ease. But like I'm sure as you've all come here, maybe you on your airline, you have a mobile application for your ticket, et cetera. And kind of at the height of the pandemic, what Ryanair did was they had essentially a travel wallet. And in order to do things like vaccination verification or maybe negative PCR tests, what they would do is customers inside of that mobile wallet would upload either their vaccination, proof of vaccination, or their negative PCR test. And what the application did was the mobile application would go and request essentially a pre-signed URL from S3. Then the mobile application would take the local document on the mobile device and then upload that into the pre-signed URL. Then what would happen is you can then go back and the mobile application then would say, I want to show that through the mobile application. Now what you could do is you could use the S3 object Lambda here to then convert that into, let's say, a PNG file, which is viewable within the mobile application. And this is what Ryanair did with their travel wallet. And what they did is they actually did a little caching exercise here where they actually did a conversion. And if it was already converted, we went and got the converted file. Or if not, we'll go and do that inline. OK, so just quick summary. So we talked about a lot of things between Eric, Jeremiah, and myself. So the key idea here is we have all of these storage services that are available to you. And what we want to encourage you as customers is to think about how do we build loosely coupled modern applications on top of these persistent storage options that we've given to you. So again, with EFS, there's options around container-based applications with serverless applications. Jeremiah talked at length about machine learning inference, media processing, content management capabilities. And we would love to continue to work with you and help you figure out how to do those things. We talked a bunch about S3 Object Lambda. We talked about event notifications through EventBridge and how you create these loosely coupled applications and extensible applications for being able to trigger many different downstream compute targets. OK, I think that's it. I do want to have a couple of closing things. These are a couple of the storage sessions and serverless sessions that may be of interest to you that will help you. Some of these are workshops. Some of these are just deeper dives on these capabilities. And we do have other learning opportunities for you as a customer. So there are storage learning resources for you to, again, if you as an organization are working to enable and build more people within your organization, here's the information for a storage learning plan. And on the serverless side, actually just yesterday, we just announced what we're calling the Skill Builder Serverless Learning Badge. So this is just another opportunity for you to continue growing on the serverless side as well. And with that, I want to say thank you for coming. If you have questions or want to discuss maybe your use cases, the three of us will be available up front, and we're happy to discuss with you any questions that you may have. And with that, we just want to say thank you for coming, and have a great rest of the conference.